Thanks for the introduction. Very great to have so many people here. In the next 15 to 20 minutes, we will have a look at Rust and using it with Zephyr. So, first we will have a very brief introduction, then we will focus on how we can use Rust with Zephyr in the first part. In the second part, we will focus on how to use C from Rust, because that's kind of a typical setup you will have when you try to introduce Rust into your ecosystem. So very quickly about me, I'm working at NOSA Engineering. I'm typically working in Linux and embedded environments. Beside NOSA Engineering, I have my own company, DevMinds, where we give technical trainings with a focus on DevOps and embedded systems. Now, who of you is using Zephyr? I mean, there must be many, right? Great, so why should you use Zephyr? Of course, because it's a great thing to use. So the same thing more or less applies to Rust. So who is using Rust? Okay, at least a few of you. So why should you use Rust? It's the same reason. It's a very cool thing to use, but there's a bit more. So one thing is, as Europeans, we always do what the wise house tells us to do, so stick to it. I mean, they mentioned, forget about C and C++, use Rust, it's memory safe. There's also support in Linux. Kernel is kind of, as you can see below, in December last year, Miguel mentioned in the Linux kernel mailing list, Rust experiment is over, Rust is here to stay. And of course, there are plenty of technical reasons. I mean, just take your favorite AI or search engine, or even better, try it out. So how is it with Rust and Zephyr? Initial support for Rust and Zephyr started in early 2025 with release 4.1.0. You can check documentations online. There's some documentation available. Zephyr Lang Rust, it's kind of what it's called, is hosted on GitHub in the Zephyr namespace. And it's worth to mention there's some videos already available by David Brown. He's kind of the maintainer of this module. So it's a very good thing to have a look at those. Now, what do we need to get started? So first, sorry, somehow marked everything. Need to get my mouse pointer. So first, it's an optional module. So if you want to use Zephyr Lang Rust, we have to enable it. Once we enable it, we will end up with something like this in our workspace. So we get this Zephyr workspace. We have these modules, Lang Rust. And on the right side, this is kind of the content that's within the Zephyr Lang Rust. And we will have a look at what all those things within there do. Just a small reminder, if you're using or try to use Zephyr Lang Rust, you might want to pin because there were some changes, especially in the GPI or API in the latest commits on GitHub. So if you use the one shipped with Zephyr 4.3, you might be a bit confused about the documentation. Now, to get started, we need, of course, a project. So we set up a simple example. We can either follow the documentation, or there's also some examples on the Zephyr Lang Rust GitHub repository we can start with. You will have a similar setup like shown here, very trivial. So we have application, we have this source lib.rs file that's gonna be our Rust code, and we will have a look at it or what it could look like in a minute. We will have those cargo toml files, which is the Rust project file. And there's some quite known things like a CMake list, the West YAML, and so on. So, for example, a very trivial, here's an example of just a hello world doing nothing more than just saying hello from Rust. We have this extern C Rust main, which is the entry point. We're going to see later on why it's called like this. There's a log module available from this Zephyr Lang Rust stuff we can use to print out things. And we have to use this no standard macro at the beginning because we are running in a no standard environment because we're using Zephyr. So how does this plug together with Zephyr and C? Now, it's a bit small, but maybe you still can see it on the right. There's more or less a simple sketch of the setup. So we have Zephyr, we have things like kconfig, we have device trees, we have all the APIs and the stuff available from Zephyr. We have this Zephyr lang Rust, which is providing a main C, we're gonna see in a minute. It has some functionality to parse this kconfig mod stuff and device tree. So to make it available in Rust. It has some bindings available to the Zephyr API. So there's some functionality available from Rust we can already use out of the box. And then finally, we have our lib.rs file, which is linked together with the main C from the module as well. So then we end up with our Zephyr binary. Now, you might have read it up on the left, but basically what happens is we have this, it's a bit stripped down, but we have this main C provided by the Zephyr lang Rust. And it just kind of calls this Rust main as an action void. And if we compile it together, so the Rust code is compile a static library, and that's how the mechanics work. So it calls Rust main, and then we execute the code. Now, if we have a look at the building blocks to make this available, within this Zephyr lang Rust, there's, for example, a Zephyr build crate, which is responsible for parsing kconfig to make it available from Rust. We're going to see an example later on. There's Zephyr macros, which is providing some simple macros, for example, to spawn a thread from within Rust. So we create a Zephyr thread. There's Zephyr sys, which is providing the low-level bindings to the Zephyr API, or at least to some of the Zephyr API. And there's the Zephyr crate, which is currently containing the available abstractions for Zephyr API. So there's a device flash available, GPIO, and so on. And there's more. I mean, you can check the official documentation of all those modules. Now, I have just some examples. Probably I will go through quite quickly because of time, that we have some time for the second part. You can use GPIOs, logging. It's just some examples here. You can read it up later on. You can create threads. There's already things available to use Zephyr timers from Rust. You can use work queues and so on. Now, it's not covering everything from Zephyr. It's just a very minimal thing. You can build your application, you can compile it, and there's some modules available you can already use from Rust. But what do you do if it's not yet available? So for this, I'm using this very simple demonstration hardware. We built this for DevMinds for training purposes. It's based on Raspberry Pi, and you have some LEDs, some GPIOs, you have an LED strip, and that's exactly what we want to use here. So yeah, I'll skip this. It's just how to get started with everything. You might even need to patch something to get all the toolchain running up and Rust Analyzer working. But now we have this board. We want to have some code using hardware. So we go from the hello world to the Blinky as a first step. So we have our known Rust main, but instead of just printing something with a logger, we now see that there's some functionality available to get the LED from the device tree. So we have this Zephyr device tree aliases LED1 get instance. This unwrap is kind of just fail on panic. Then we can check if it's ready, otherwise we loop, then we configure it as output, and then we just blink it. So very simple. Now we want to extend this to access the LED strip handling. Now, how can we even call C code from Rust? Now with Rust, we have this foreign function interface. You can look it up with a little C from Rust, interoperability with C. And this allows us to call from other languages functions. For example, C functions, or we can access C types. There's also support for other languages. On top, we typically implement kind of a Rust wrapper around these unsafe C function calls, which make them available to run as normal interface later on. So these bindings we need to have, we can write them manually, or we can use bindgen, which allows us to generate these bindings automatically from Z code. And that's what I'm going to show in the second example. Now first, how does it look like if we start just by doing manually? It's again a bit a toy example. We have our library here with the send function with the signature. So if we write the bindings by ourselves, we would just more or less write unsafe x&c and map everything to the Rust world. Now, we could call in our code this function always as follows. So we have an unsafe block, and then we call this send function. Here we just have a simple wrapper which provides a Rust interface more or less without unsafe, and it just returns true if return code is 0 and false otherwise. This allows us to finally call this send function like this. Now, if we want to maintain all these bindings for a lot of code, we probably want to use bindgen. And by the way, that's also what Zephyr Lang Rust uses for itself to access the Zephyr API. So what do we do to access or to create those bindings automatically? Now, we want to use the LED strip functionality from Zephyr because it has support for a lot of LED strips. Now, to generate bindings automatically, we use bindgen. So we create a wrapper header file where we just list all the headers or we want to access later on. Then it requires quite a lot of configuration. There are even some things stripped out here. So we reference this wrapper to make sure bindgen knows what API headers it has to look at. We have to configure the target platform for Clang running in the back. We can specify some allow lists to define which functions and types we want to generate bindings. And if we run everything together, then we might end up with something like those bindings.rs. And just as two examples, now we have this LED strip update RGB and LED strip length. That's what it looks like if we generate it automatically. Now, how do we use this? We could just always write in our code unsafe LED strip update RGB, and then we call the C functions through the bindings. Or what we typically do, as I mentioned before, we write some Rust code around it. Here's a LED strip module. So we have this LED strip struct with device tree, name, device handle, number of pixels of the LED strip. We create some new, some init, and this update function. And this allows us to call it later on more or less like this. So we have this LED strip new, it's the alias from the device tree. Then we can initialize all the pixels. And then finally we update it and we handle the error code, which is implemented in Rust. So actually it's more or less, I can show you here, we can have a discussion afterwards. So it's just basically lighting up. You have some GPIOs, so you can click around and then you can change colors, nothing really fancy. Just to show you, this was entirely written in Rust. So we are using the logging and the GPIO and the threads and everything from the Zephyr Lang Rust module. And for the LED strip, we're using bindgen to generate the bindings, and we created an own LED strip module to be used from within Rust. Now, just maybe as a bit of a summary, I mean, if you use AI, everybody's using AI today. So with Zephyr, you have a big advantage that typically you have all your sources, your build artifacts, everything locally. So if you use AI, it has access to anything you use. And it's quite powerful if you debug even some things like device tree stuff and so on. It's not so useful if you try to get Rust and Zephyr together working. Maybe not too much training data. But once it's up and running, it's quite powerful again, because then you're basically writing Rust code. And for example, there's this Night Rider mode on the LED, it's just written by AI. Just ask it, hey, can you make a cool Night Rider thing? And there you go. So finally, I would say Zephyr with Rust is a very powerful combination. Now, I hope you can't read the next sentence, but I will continue. So get your hands on, experiment, and start contributing. Thank you for attention.